Okay, in this video we're going to talk about what a polynomial is and its definition, and then we're going to work a little bit with adding and subtracting polynomials. So first, I wanted to kind of break apart this word polynomial. You might have heard it before, but I think it's important to understand what it means. So this word poly means many, so it means multiple, and then nomial is a name or a term. So the word polynomial means many terms. I'm going to add a little s here. So a term in math is any thing that kind of exists by itself. So 2 is a term, or x squared is a term, or 3x, or 5001. All those are terms, right? A polynomial is when you take a bunch of these terms, many terms, and you add them together or you subtract them. So what I just wrote, this 2 plus x squared minus 3x minus 5001, that is a polynomial. It's a string of terms that are added together. And important things about the terms of a polynomial is that the terms have to be constants, like 2, or powers of x, like x squared, or x to the 5th. Something like this, where it's a power of x with a coefficient, that's also okay for a polynomial. Things that aren't polynomials that you might have seen are things like 2 to the x. That's an exponential, not a polynomial. Or what else have you seen that you might, stuff like that. So let me just put a big X through that so that we don't get confused. That is not a polynomial. So we're going to be dealing a lot with polynomials in this unit. So we're just going to be dealing with these things like the first thing I wrote, 2 plus x squared minus 3x minus 5001. So the cool thing about polynomials is they behave very similarly to integers, which we are super familiar with. So we're going to talk today about adding and subtracting polynomials. So first I wanted to show you an example of adding and subtracting an integer and show you how that's similar to adding and subtracting a polynomial. So say I want to do 137 plus 22. Now hopefully we can all do that addition. I'm going to show you a way to do it. It's kind of a long way, and I would not recommend doing this with integers, but it's going to help us see how adding integers is like adding polynomials. So I'm actually going to separate this 137 into 100 plus 30 plus 7, and the 22 is the same as 20 plus 2. This kind of goes back to place value. Hopefully it's kind of bringing back to your elementary school days. But if we were to add this way, then we could start looking at what's in common with some of the terms they're adding together. So for example, this 7 and this 2, they both are just one number, right? They're less than 10, and they're considered in the ones place. This 3 and this 20 have something in common because they are multiples of 10. So what we could do to add these together is we could add these terms that are similar to each other. So the 30 plus the 20 would give me plus a 50, and the 7 plus the 2 would give me plus 9. So I have this now string of terms that are added together by combining things that were similar to each other in the previous step. And we know we could go one step further and simplify this to 159. Now I'm going to show you how this is similar to adding polynomials. Okay, so let's say I'm dealing with a similar problem, but now I'm going to throw some x's in there. So I'm going to do x squared plus 3x plus 7 plus 2x plus 2. Okay, a couple things to notice. First of all, I'm dealing with two polynomials. This first set of parentheses is a polynomial, and the second set of parentheses is also a polynomial. Other thing that's important to recognize is that I actually use the same coefficients in my polynomial problem as I did in my integer problem. So I've got a 1, 3, 7, and a 2 and a 2, just like I had 137 and 22. So I'm going to break these things apart. I'm just going to go ahead and take away the parentheses. So we can look at this all the same as the same polynomial. We know we can take away the parentheses because addition is commutative, so it doesn't matter what order I do the addition in. And now I'm going to just start looking at things that are similar to each other. So there's nothing else that has an x squared, so I'm going to leave it alone. Now I have two terms that have an x. I have a 3x and a 2x, and then I have two terms that have no x's in them. So I'm kind of going to combine those two. And I'm just going to think about combining these what we call like terms. Like terms just means that they have the same power of x on them. So I have a 3x and a 2x, which gives me a total of 5x, and then I have a 7 and a 2, which gives me a total of 9. So this is the sum of the two polynomials that I started with. And that kind of gives me, this is kind of a parallel to show how integers and polynomials can be added in a similar way. So the big idea that we saw here is that we combined all the terms that were the same, all of the like terms. You're going to hear that term a lot in this class and in other math classes, the idea of combining like terms. So I'm going to go ahead and clear myself some space, and we are going to do some more problems that are a little more complicated. So scroll down a little bit and get some new polynomials out there for us. So let's look at these two polynomials. Okay, so say I have these two polynomials, I'm trying to add them together. The first thing I'm going to do is try to find my like terms. So I notice I have two terms that have an x squared in them, and I have two terms that have an x in them, and then I have just one term that has no x's. It's just a constant. And since everything's being added together, I'm just going to go ahead and start combining all of these like terms. So I get a 7x squared, I've got 5x's, and then I have the 1 left over. It's as simple as that. That's all it is. Now, one thing that I do want to point out about these two examples that I just did is that these two examples, both this one up here and this one down here that I'm going to box and star right now, are what we call standard form. So a standard form for a polynomial means that you start with the biggest power of x, or the biggest exponent, and you go down from there. So see how I started with, let me get my highlighter out. I started with everything that had an x squared in it, and then I went down to the x's, and then I went down to things that don't have any x's in them. If I had like an x to the third power, it would have gone as the first term. So we basically want to, when we write our polynomials, we want to try to write them in standard form and get in that habit, so that we're decreasing the powers of x with each thing that we are adding together. Okay, we've seen a couple addition problems. Let's throw out a subtraction problem. Let's see this one that I have right here. 3x squared plus 2x minus 4x squared plus 3x minus 1. Okay, we're going to handle this pretty much the same way. First, I'm going to kind of identify some like terms that I have. I have a 3x squared, I have a 4x squared, I have a 2x, and I have a 3x. So we know we're going to eventually be able to combine those terms together. What we have to be careful with is that we have a subtraction sign. So we have to be careful that when we start thinking about combining these like terms, we are subtracting everything that's over in this set of parentheses over here. So I'm going to show you one way that I like to do this that helps me to keep track of all of these, making sure that I'm subtracting the whole polynomial at the end. So I'm going to get rid of my parentheses. The 3x squared plus the 2x, those are just kind of hanging out up front. And then I have to subtract every single term inside of this second set of parentheses. So I'm going to subtract a 4x squared, I'm going to subtract a 3x, and then I'm going to subtract that negative 1. Because I'm subtracting down here, it's going to be minus a negative 1. And now I'm going to change this minus negative 1. We'll do that at the end, never mind. Now I can start combining like terms. So I can say I have a 3x squared and I have a minus 4x squared. So 3x squared minus 4x squared is negative x squared. I have this 2x minus a 3x. That's going to give me a negative x. And then I have this minus a negative 1, which turns into adding 1. So notice here that, again, our polynomial is in standard form. I just chose some that always put it in standard form. Sometimes you might have to rearrange at the end to make sure that your polynomial is in standard form. Another thing to recognize that's important about this problem is that we distributed this negative. Some people also like to think about it as distributing this negative into each of these pieces. And that gives me the negative 4x, the negative 3x, and the minus negative 1. So let's just write out a few, kind of make sure we have written down the important components of adding and subtracting. One, Adding polynomials is like adding integers. You're combining like terms and you're... Oh, another important thing that's the way it's similar is when you add two integers together, you get an integer. Uh-oh, what did I just do? I zoomed in a ton. I'm sorry, guys. Pause. Okay, so when you add two integers together, you get an integer. When you add two polynomials together, you always get a polynomial out, which is pretty awesome. Okay, another thing that's important is that we are combining like terms. That's a really important component of making sure that you're adding and subtracting polynomials correctly. Another important thing to remember is that you want to make sure you distribute your negative signs or your subtractions to everything inside the parentheses that the subtraction sign is in front of. And then fourth, you want to put your polynomial in standard form. And these are all just different components of making sure that we're adding and subtracting polynomials correctly. So we're going to talk more about multiplying and dividing polynomials in a little bit. So that is it for this lesson.